Hey there! Today we are going to use Unity and JetBrains Rider to build a game inspired by a retro classic called Asteroids. And in that game you control a player and you can rotate it left and right, you can thrust forward and you can shoot at incoming asteroids that fly into space. Let's sit down, fire up Unity, grab a coffee and let's go. The first thing I'm going to do is import some of the assets that I downloaded or at least added to my library in the Unity asset store. So from the window menu here, I'm going to open the package manager, go to the packages that are in my assets that I have added in the asset store, and then I'm going to download a couple of the assets that we'll be using in the game. So the ones that I'm interested in are the breakable asteroids, and by the way, you can find the names and the links to these assets so you can add them to your own game as well in the description of this video. I'm going to include the breakable asteroids, just import them and add them into my project. I'll go with all of them, probably too much, but it doesn't matter in this case. All right, I will also include the particle pack, which we are going to use for explosions, etc. Now, since we will only be using explosions, what I will do is not include all of them, because there's more particles that are various effects for other things that you can model in the game. And what I'm going to do is just import the fire and explosion. So let's deselect all and just import fire and explosion effects into our project here. The next asset we will need is of course a space fighter or a ship that we can use. So I also have a spaceship fighter IB asset. Let's import that one as well. Just add everything into the project. And then just because we are going to have this game playing out in space, I'm also going to import some space starfield backgrounds so that we have a nice space look and feel of the entire scene in our game. Also import everything. Again, way too much, but let's go with this. All right, with that, we can start working on the game. If you look at Unity, the default skybox you see here with the blue horizon and the brown terrain and a horizon and so on, doesn't really look like space. So the first thing we are going to do is create a custom skybox. And a skybox is really a cube with a different texture on each face. And Unity will place our game inside of that cube so everything looks like space no matter what direction we look at. So to do that, what we are going to do is create a new material. And that material can get a name. Let's call it starfield. And in that material, we can start configuring what it should look like. And we want to make it look like a skybox. So we're going to change the shader here and make that into a skybox, a 6-sided skybox. So again, it's like a cube with different faces. It's 6 faces, so we want to have 6 different faces there. Now, from the assets we've downloaded, we can now make use of the textures that are in there to populate all of those different faces of that cube. So from the starfield materials here, I can go into textures, find the starfields, maybe even some nebulae. Let's drag this one into the front. And let's take some starfields for the other ones. And by the way, you can click the select button in these squares and just use those to work with. But what I'm doing here is simply dragging and dropping from the Project Explorer, which makes it much easier to set up a material like this. With our new material in place, we can now replace the rendering of the default skybox that we have in Unity. So to do that, you can go to the window menu, to rendering and then lighting. In there for environments, you can see that there's a default skybox material, which comes from Unity. But by adding our own custom material, we should now be able to use our starfields that we just created. There we go. And as you can see, the moment we select this one, you already see that the starfield looks much nicer in the scene that we have here. There's another thing that we are going to change here, and that is the camera position. So we want to have this 3D effect so that we can have rotating asteroids and everything like that. But also we want to make this top down. So we essentially have a 2D view of the entire world model while still being able to use 3D models in everything that we have here. So what we're going to do is in the main camera, change the position and the orientation of it. So we will move the position of the camera to the center of our stage. X and Y coordinates will be 0. And we'll move it slightly back so we have a wider angle of view later on in the game. That's pretty much it. This should already be much nicer to look at. One last thing we will do in the setup of our scene here is change the directional light. So in space, typically when you're not close to a sun or another bright object, you don't get a lot of light. Now for this game, to make it look a little bit nicer, what we are going to do is make the light a little bit brighter. There is some background light in the space that we are building this game, so let's change this one to 2. You will see later on that this really makes the shadows in the game look much nicer than without that additional light that is there. Right. Next thing we are going to do is add our assets to the game. So what we will do is add a spaceship and add an asteroid into the game that we have here. So for the spaceship, we also downloaded some prefabs. There is prefab 4, which I quite like. That's a very nice spaceship. So you can simply drag that into the scene and you will see that this is massive. It's really large. So what we are going to do is scale it down a little bit so that it's much nicer and much better for the game that we are building. We'll set the position of this prefab to 0, 0, 0. So again, this spaceship is right in the middle of our scene. We'll also rotate it on the x-axis. We'll rotate 90 degrees. Again, I mentioned we want to have this top-down view of the entire game scene, and this is going to make that happen. And then we're also going to change the scale. Let's say 0.16, 0.16, and 0.16. And there we go. Already much nicer. You can see the spaceship in action, and if you actually rotate the scene like we want to have it on screen, this is what the view of the game will be. So you can see that the prefab and this spaceship have now been added to the scene. Right, let's zoom out a little bit, and then let's look at the asteroids that are there. So also in here, there should be asteroids. I know rock 14 looks quite nice, so let's also drag that one in. You see that the rock is now on the screen, which is very nice, and we are going to make some additional changes to that one. Whoops, deselected the wrong one. This one we are just going to move to a different location in the game, let's say 2, 4, and 0. The z-axis is really important because we want to make sure that the spaceship and the asteroids are on the same z-axis, so that whenever we start firing bullets later on in the game, that we can do collision detection and everything so that the coordinates match up and line up. Right, let's set the rotation of this one as well. We are going to rotate with 45 degrees just to make the view a little bit nicer, and then set the scale to 1, 1, and 1. And when you switch to the Unity play window now, or to play mode in Unity, you will see that we now have this spaceship and we have that rock that is on there. By the way, this ship still looks very large compared to the asteroid, so I'm going to make the scale a little bit smaller even, and maybe make it 0.016 instead of 0.16. Just to make sure that the asteroid and the ship are somewhat in the same size region. So if we zoom in a little bit, you will now see that this is much nicer. We now have a spaceship and an asteroid that look more or less the same in terms of size. Right. You saw in play mode, and by the way, if you go back now, you should again see that the size of the spaceship and the asteroid line up much better. But if you press any of the controls there, nothing is happening. So the next thing we want to do is add some interactivity, do some coding, do some scripting to make sure that we can move the asteroid, can move the spaceship around, and things like that. So let's do that now. Exit play mode, select the spaceship, and then in the spaceship here, we are going to add a new component. It's going to be a script, and you can just search for script, for example, and then say new script. And we are going to call this script player controller. The player controller is going to be the script where we will essentially control the player. So we will add some properties to that one so that we can control what the behavior of the ship will be in the scene that we have. Now, Unity adds this player controller script in the root of our assets folder. I would usually in my own projects move this one to a scripts folder, but you can keep it there for the demo that we have here. If you double click it and you have Rider configured, you will jump into the code editor, into Rider, and you can start writing some code. Now, what we are going to do is first of all set up the structure of this player. So our player will be able to rotate, it will be able to move, it will have a laser, and it will be able to fire lasers from one of its cannons. So what we are going to do is add some serialized fields, and again, using Rider, you can use a shortcut for that, S field, hit tab, and you have a serialized field that you can add. It's going to be a float, and I mistyped that one, float, yes, and it's going to be called rotation speed. We'll add another one, which will be also a float, and that's going to be our movement speed. We're going to add another one. I know, lots of fields to be added. That is going to be a game object that will reference a laser that we can fire on later on. We're also going to add another serialized field, which is going to be an array of game objects, and I'll talk about this one a little bit later. That's going to be our cannons. We will also need a serialized field that is going to be a float, which will be our cooldown. Reason for this cooldown is that we want to make sure that we don't just keep increasing velocity when the spaceship moves around. So we're going to add a little bit of a cooldown between movements and the fact that you can only shoot, for example, let's say by default every 1 second, so that you don't just fire a stream of cannon fire continuously from here. We will also need a private rigid body. And that rigid body is essentially a way to subscribe to Unity's physics engine. So what we want to do is keep track of the current rigid body for our player. And that rigid body is essentially an object that defines how everything should interact with the entire physics engine. Is there gravity? If you move, do you slow down? Is there drag, etc.? We're also going to add a private, and not that one, a private integer, and that is going to be the current cannon. I'll already give you a slight pointer here. The assets that we added to the scene of our spaceship has 2 cannons on the ship, and we want to alternately fire from one or the other cannon. So we simply want to increment this counter and loop through all of the cannons so that every single time we fire a laser, it comes from a different laser. Let's also add a private float, and that is going to be the time. I'll explain that one later on, but just keep that in mind. We are also keeping track of the time. In our start method, which is called essentially whenever we go into play mode or whenever the scene is loaded, we are going to assign that rigid body and say we want to get the component from our current game object called rigid body. Now, we didn't add any of this yet, so let's jump into the Unity editor so we can start hooking up things. So in the Unity editor, for our player, we now have this player controller script, and you see all of the variables here that we can set for that spaceship. So what we are going to do is set a couple of things. For example, the rotation speed, we are going to set that one to 90, good rotation speeds. The movement speed, we are going to set to 200. Cooldown, let's keep that one at 1 second, that's perfectly fine. And then we have to assign the cannons and the laser. Cannons is easy. We now have an array here. And if you expand the prefab of our ship, you will find cannon 0 and cannon 1 there. So in our script, what we can do is simply select both of those cannons. And in the prefab, those locations and the coordinates of those cannons are already known. So we can now access them from our player controller and work with them to fire the lasers. One thing that we don't have yet, though, is the laser that we are going to fire. So what we are going to do is in the hierarchy here, we are going to create a new capsule, a very, very simple object. Like you can see, it's like a pill-like object that is going to be our laser. So let's also name that one laser. And we are going to configure this one so it looks more or less like a laser that we want to fire. Position all 0 coordinates in the middle of our scene. We are going to rotate this one with 90 degrees, so it's in the same direction as our spaceship is facing. And also the z-axis will be 90 in this case. And scale, compared to the spaceship, it's really big, so we are going to move to 0.2, for example, 0.2, and that's it. Now, this laser and let me quickly zoom into it. It's still in the ship, but let's keep it there. This laser will collide later on with asteroids. So we will need an object to be able to determine whether there is a collision with the laser and something else. So what we are also going to do is add a collider to this capsule, and it's actually already there. And you can configure it as a collider. So this is good. We have a collider here. Let's keep the default and work with that one. All right. One thing that is missing is a color of the laser. Right now it's bright white. You can keep it bright white. We could go with that, but just to show you, you can also create a new material. And that material is going to be a very simple standard shader with a rendering mode opaque. If you set a color there, the albedo, you can do red, for example, or a bright yellow laser or whatever. You can give this material a name. Let's call it red. And then on the laser, you could select that material as the renderer that you may want to use there. But that's completely up to you again, and yeah, you can select how you want to render this one. Since I created the color, I am going to replace this one with the red laser, and as you see on the scene, it now is a red laser. Awesome. Now, the laser shouldn't be on the scene all the time, so instead of having it in the hierarchy of our scene, what I'm going to do is convert this laser into a prefab. And a prefab is like a template object that you can reuse in Unity. So what I'll do is simply drag it from the hierarchy view into our project view. And what will happen is that our laser is now a prefab. And if you zoom at the entire scene, you can now add as many lasers into the scene as you want. But again, I mentioned I don't want them on the scene, so I will remove them again so that we don't mess up whatever we have on the scene here. All right, let's remove that one using the delete there. And we now again have a clean scene with just the asteroid and the ship that is on there. All right, returning to the ship, we have our player controller. We created that laser, so the only thing left now is to say, okay, look, whenever I want to fire a laser, I want to use the assets that I have and my newly created laser and also link that one up to our player controller that we have there. Pretty cool. I mentioned that we also needed a rigid body in our player controller script, again, to subscribe to the physics engine that is in Unity. So that's another component we will add here first, and let's say we want to add a rigid body. With a mass of 1, that's perfect. We're going to add a drag of 0.5, which means if you accelerate the spaceship, that over time it starts slowing down because there is a little bit of drag. I know typically there's no air resistance and all of that in space, but just to keep the game mechanics a little bit more interesting, we are going to add a little bit of drag. There is an automatic center of mass, automatic tensor, gravity. We are going to disable because we don't want our spaceship to fall down to the floor all the time. So let's disable gravity. And we are also going to put some constraints on this rigid body. So what we don't want is that whenever our spaceship rotates or moves around and so on, we want to freeze that Z coordinates, again, because we want to be able to have lasers collide with the asteroids, etc., and we want them all on the same coordinate system. And we're also going to freeze the rotation of our spaceship, at least for a rigid body, so that we cannot influence, or at least the physics engine cannot influence any of those values whenever it runs its updates. All right, now let's switch back to Rider and start working on the code. And by the way, before we had those serialized fields where you could hook up the rotation speed, etc. What's really cool here is that in Rider you can now see whatever is attached. So for example, to the laser, we have that laser attached and we can actually jump into Unity again and find that laser prefab in the Project Explorer, which is pretty cool. Anyway, in the update methods, and that's the method that is called on every frame whenever there's an update to be done, we are going to start controlling our laser. So let's add a comment there that says laser, and let's start writing some codes. What we are going to do is check that time variable, and if it's larger than 0f, so when the time has not expired yet, the only thing we are going to do is from the current time, we are going to subtract the delta time of the current frame. So what is going to happen is whenever we fire the laser, this time is going to be set to the current time, or to 1 second, essentially that cool down period that was there. And then for every frame that is rendered, we are simply going to reduce and reduce and reduce that time variable. And whenever it's 0 or lower than 0, we can fire again and do the entire thing again. If the time is not larger than 0, then we are going to listen for inputs. We are going to listen for the input key, and we are going to listen to keycode.space. We are going to listen for people pressing or for the player pressing the space bar so that we can fire those lasers. The code that we're going to write in here is going to make use of the laser that we are going to fire. So what we are going to do is we want to have that laser originate from either the left cannon or the right cannon. So we want to keep track of the laser origin transform, which is going to be the transform of one of our cannons. And I should really learn how to type. This is not, of course, yet of our cannons. This is the transform of the spaceship that we have. And the transform is really the coordinates of the current spaceship. So if there's no cannons, worst case, we simply fire the laser from the center of our ship. It's not going to look pretty, but still, if we would forget to hook up all of the cannons in our asset that we have here, or in our script that we have here, it would still do something, and it would still show something. If the cannons do exist, if the cannons.length is larger than 0, then we are going to do some stuff. The laser origin transform is now no longer going to be the coordinates of our spaceship. It is going to come from our cannons, and that's going to be from the current cannon, and we're going to increment that variable in one go and simply go with that transform. If the current cannon is larger than the cannons.length, then we want to set the current cannon to 0 again, so that we can iterate again and again and again over that array of lasers that is there. Now, we didn't yet add the laser to our screen or to our game, so what we're going to do next is instantiate that laser, and full line completion here in Rider is already giving us a good clue of what is going to happen. So we instantiate our laser prefab at the position of that laser origin transform that we created, and with a default rotation. That seems perfectly fine. I am going to, however, use the rotation of the transform of the spaceship, so that when the spaceship rotates left or right, the angle of attack of our laser should be in the same direction, so we are going to reuse the same location there. Now, there is one thing. We also want to add some momentum to the laser. So what we are going to do, we don't want to add momentum. We're going to do that later on. But what we do want to do is from our current laser origin transform, we want to transform that point because the center of the cannon is not where the laser originates. We want to have the end of the loop of the cannon where we fire the laser. So what we are going to do is move our position forwards a little bit, and let's say by 2, because that should be essentially the end of the cannon, so that looks a little bit nicer. Pretty cool. And if we now go back into Unity and we would go into play modes, you will see that cannons work. If we press the space bar, you will see that all of a sudden there is this laser showing up. If I press it again, you will see a second one, third one, fourth one, etc. But they're not moving yet. Next thing we are going to do is add some movement to the laser. Now, our laser is currently a prefab, so we can jump into that laser prefab and start customizing this template object with things that we want to add. So what we are going to do here is we are going to add a new script. Let's say new script, and this is going to be the laser controller. There we go. Open that one up in Rider as well, and we can start coding. So in our laser controller, what we want to keep track of is, first of all, a field that is going to control the speed of our laser. I don't want to hard code the speed here. I want to change this in the scene so that we can essentially just configure whatever the speed of the laser is going to be and what it should look like. In the start methods, there's not much that we are going to do, so I'm going to simply remove that one, and let's also remove some of those comments. What I'm going to do in the update methods is on the current transform, so again the coordinate system of the laser in this case, we are going to translate that one, and we are going to translate it to a vector.forwards, vector3.forward, sorry. And we are going to multiply that vector by the speed and again the current time of the frame. So that whenever a new frame is rendered, we are simply going to move forward and change the direction or change the location of where we are going with that laser. So this should be enough. One additional thing we are going to do is press the Command N key so that we can create something new, or actually I can use full line completion here as well. We are going to subscribe to the Unity event function called onBecameInvisible. Reason for that is whenever the laser moves forward and leaves the current screen, whenever it becomes invisible, there's no more need for that laser. It's not going to bounce around or things like that. So essentially what we want to do is whenever our laser becomes invisible, we are simply going to destroy the game object that is attached to this script. And this should be more than enough to have movement on every frame, but also to remove the game object and not have too much memory allocations and things like that in the game, or objects that we don't actually need. If we now go into play mode, just to demonstrate what we've just built, we should be able to press the spacebar and have movement, but that's not yet working. And the reason for that is very simple. In my laser, I did not yet set the speed of our laser that we have there. So not sure what to go with, but let's pick any value here. Let's maybe go with a 4. Let's go with 4. Back into play modes. And we now have lasers. They are not lightning fast, so we probably want to increase the speed there a little bit more as well. Let's make it a 20. That's going to look much nicer, I think. All right. We now have lasers moving. We can shoot lasers from the ship. Let's see if we can add some movements to our ship as well. So to do that, we go back into Rider, back in that player controller, and underneath the firing of our laser, we are now going to start listening for other input and other keys that are being pressed to do other things, and essentially rotate and make sure that the ship thrusts forwards. Cool. So what we will do here is listen for inputs that comes in. So what we will do is, and maybe also add a small comment there and say we are building the player movements here. If the input .get key is key code up arrow, and I'm going to use the up arrows, but you could use keys like W, S, A, D, whatever you want to add there. I'm just going to go with the arrows here. If the inputs.get key is up, we are going to make use of that rigid body that we have. Again, control the physics interaction in Unity. Add a force to that one and say we want to transform this one forwards. And we want to do that using our current movement speeds times time.delta time. Reason for that, again, is whenever the frame is rendered, we want to have a nice cohesive movement that is going on. So we are going to simply use that direction. Going to copy this bit of code and make that the down arrow. If we press down, we want to reduce the movement speed. So let's just add a minus there, and that should be enough. If the input.get key equals the left arrow, we don't want to add a force. Instead, on our rigid body, or actually on our transform, because this doesn't really interact with the physics engine in Unity, we're going to use a transform and simply rotate it around. So we are going to rotate it down times rotation speed times that delta time again. That should rotate left. Again, I'm going to copy this bit and do it for the right arrow as well. This one is not going to rotate down, it's going to rotate up, and the down and up here refers to the coordinate system that we used. I configured the camera to look on a specific angle and a specific coordinates, and yeah, these are essentially a result of those settings that we have there. So let's go back into Unity and let's see if our ship can now move around or not. Let's press the play button and we can now move around, we can rotate, and it actually works, and we are speeding up. If we keep pressing the up arrow, we can move around, and if we press the back arrow or the down arrow, we go backwards as well. So we can almost hover in space. Pretty cool, no? Very simple script to move this spaceship around. All right. Another thing we want to do is make sure that when our ship moves up or down or whatever, reappears at the other side of the screen. So right now I'm just floating into deep space. I have no idea where my ship is. Maybe if I look at my game inspector, I can probably look at where my ship is currently located. But if I double click it, yeah, I don't even find it. Anyway, we don't want that. We want our ship to reappear at the bottom of the screen whenever we go beyond the borders of the screen. So what we are going to do is we are going to add a new capsule collider to our spaceship. So if you look at the spaceship, we are going to add a new capsule collider. And that collider is going to subscribe to the fact that we collide with something. In this case, we are not going to check whether this does collide with something, but we are going to make use of the collider to sort of determine what the shape of the object is and whenever we go off screen. So we now have a capsule collider. If you look at the capsule collider, it's still very small. It's not even visible on the spaceship here. So we will have to set the radius of this capsule collider. I think 60 would probably be good. And on screen, you now see that there's this capsule around the spaceship. This means that whenever this entire thing is off screen, we can do something with it and work with that one. I'm also going to change the height a little bit and go with that. And I'm also going to set the fact that this is a collision trigger. Cool. Back into our player controller, we will now have to build something to make sure that we see if the player is visible or not. So what we are going to do is move through screen borders. That's going to be the comment there. In the update method, we are going to check if our player is visible. And if it's no longer visible, we are going to do something with it. We want to keep track of the current player transform. And it's going to be our current position. We want to keep track of the current coordinates. What we also want to do is keep track of the screen center, because that's going to help. Our screen center is coordinate 0, 0, 0. So we essentially want to move around based on that screen center. The screen center is going to be for our camera.main, so the main camera. We are going to convert a screen to world points. What that means is essentially in our world, we have this coordinate system of 1, 2, 3, 4, 5, etc. On screen, we have coordinates that are typically your entire screen resolution, and we want to convert between the two. So what we want to do is we want to convert our current screen.width divided by 2 with our current screen.height divided by 2, and then the z-axis is going to be 0. And that's going to be our screen center, but now converted into coordinates that Unity understands, that are no longer related to or one-to-one related with the screen resolution that we have in the game there. And then what we're going to do is set our current transform dot position. We are going to set this one to a new vector tree. That is going to be our screen center.x, so that we take the center of the screen.x. We use our player transform.x, and we simply subtract it. So we are essentially inversing the x coordinates of our screen there. And we are going to do the same thing with the y coordinates. Simply take the screen center.y, and we subtract our player transform.y from that one. And again, the z coordinates are going to be 0. One more thing to implement, and that's our player is visible. We need to have a method that essentially tells us whether the player is visible or not. So what we are going to do is we are going to look for that collider that we have on our components of our game. Look for that collider. We are going to add a new one later on. So I am going to get components so that I get all of them and simply select the first one where it is a trigger, because that is the behavior that I want for this collider, and I want to make use of that one. I also want to calculate the planes. What that is essentially calculating which parts of, and I'm using the geometry utility here, and then calculating the frustum planes. What this is going to do is from the position of the camera, it's going to look at the entire game screen. I have to, of course, set the camera.main as the starting position. It's going to calculate all of the visibilities at different layers of the game that we have on screen there. And with that information, I can actually check using, again, that geometry utility. I can test whether those planes, the camera planes that we are calculating with, whether they overlap somehow with the bounce of the collider that we have added to our player here. So I know this is a lot of stuff to unpack, but essentially we're looking at the coordinates, looking at the bounce and position of everything that is in there, and then using that to calculate whether a player should be visible or not. Quick sidestep, you see that camera.main here, but also getComponents is underlined. This is an expensive method invocation. So in Unity, if you would look at all of the objects attached to your current game objects, that's an expensive operation. We are doing that inside of our update method. So in every frame, we are doing this entire walking through the object tree that is there. So it might be interesting if you see this red underline, and it's an expensive method operation, to use the Alt-Enter menu and introduce a field and initialize it in Start, for example. And what that's going to do is, in this case, create a new field, make sure that we get all of the colliders that are there and keep track of them whenever this game object is created, so that we no longer have that performance hits. We could do the same, by the way, with that camera and assign that one in main. Up to you if you do that, but just to give you a hint that this is possible and it's definitely going to be good, especially if you have a lot of logic where maybe you don't want your frame rate to drop whenever you are calculating something. Right, back to Unity. We are going to test our code, see if it works. Go into play mode. I'm going to move up, navigate around the asteroid, and at some point I should come back, and yes, there we are. Let's try it on the left-hand side as well. And we come back. Took a little bit longer than we wanted to, probably because of the radius of that collider that we have. You can change that if you want, but this is good enough for me. Let's go with that. There is one more thing that I want to add to our spaceship, because we want to also have asteroids navigate or fly into the spaceship that we have. What we want to do is essentially listen for collisions from asteroids. So we are going to create a new capsule collider on the spaceship here. This one is not going to be a trigger, because we don't want to trigger whenever we fly into an asteroid. We want to have the inverse, where the asteroid would trigger the fact that we collide with a ship. We're going to change the radius to 0.7, so we really have to have a good collision with the spaceship, and the height to 2, and then keep everything else as is. So that's our spaceship. We can move it around, we can navigate it across our screen, and we can work with that. Now let's go on to the next thing, and let's look at making our asteroid a little bit more interactive, because right now it's still a rock that just sits there in space and does nothing. With the spaceship, we have added a rigid body to the object, and that rigid body is essentially subscribing to the gravity and to physics that are in Unity. We are going to do the exact same thing with our asteroid. So first thing that we're going to do after you select the asteroids is also here, add a rigid body. We are going to set the mass to 1, which is good. No drag. And also no angular drag. So it's just going to, when it floats in one direction, never stops, just keeps going. We're not going to use gravity, so that can be disabled. And we are again going to freeze the position of the z-axis. Again, reason for that is whenever we fire lasers into the asteroid, we want to make sure that the z-axis aligns so that we actually get a collision and we don't go underneath or above the asteroid that is there. If you want to make this game much more interesting by making it 3D, absolutely go for that and unfreeze those positions. But in this case, we want to have that top-down view, so we want to keep that lock of the z-axis. All right, our asteroid does not have a script yet. So the first thing we are going to do is add a script to the asteroid controller so we can start moving it around. So create a new script component. We will call this one asteroid controller. Let's add it to our game. And from the assets again, we can switch into Rider. In the start method here, we are going to do something similar like we did with the laser. We are going to use the rigid body. And we are going to add a force to it. We are simply going to say transform.forward so that we float forwards. And we are going to do that by some value, let's say 100 or whatever, it doesn't really matter. We are going to do that in our start so that we get initial movement and the physics engine in Unity takes care of everything else. Just like the laser, we are also going to implement the onBecameInvisible Unity event function there to destroy our laser whenever it or to destroy our asteroid whenever it goes off screen, because we don't want to keep it on screen when it's no longer needed. With that, if you go into Unity and you would start the game, you will see that the asteroid is now floating. It's not very spectacular, but already we added a little bit of interactivity. Right, the next thing we want to do is on our asteroids, we have that rigid body and everything. We also want to add a new capsule collider. So what we will do is add a new capsule collider. There we go. This one is going to be a trigger because we want it to trigger whenever we hit the spaceship in this case, and then work with that. The next thing we want to do is keep track of health, so that when the asteroid is hit, for example, we decrease or decrement the health, and that at some point the asteroid will start exploding. So what we are going to do is on our asteroids, create a new script, and you could add it all to the asteroid controller script if you want, but it's always nice to split things up by responsibility. So in this case, what I'm going to do is add a health controller to our asteroids. Bonus points there is that if you want to add health to the player as well, you could also reuse this health controller on the player later on. So we now have that health controller. Let's go into Rider, and I actually mistyped, so let's rename using the shortcut there, health controller. There we go. By the way, if you do a rename in Rider, Rider actually updates all of the Unity scripts and Unity assets and so on to make sure that we're still referencing this script, so you don't have to worry about renaming something using the shortcuts that are in there. Anyway, we want to keep track, and we want to keep track in a public int in this case. We want to keep track of the health of the asteroids. Let's set it to 100 by default. And we also want to keep track of the current health. That's going to be unassigned. Reason I'm going with public fields in this case is because we also want to access these fields whenever we interact with the health controller, so we can keep those public. I am going to add a serialized field that is going to be private though, and that's going to be a game object, and that will be my explosion that we want to show on screen. And then because the explosion is a little bit of an animation, we will look at that in a little bit. I also want to have a Boolean there that says is exploding equals false, so that we can keep track of whether we already started the explosion or not, and then work with that to not re-trigger and re-trigger and re-trigger the explosion whenever the health decrements. All right, in here, what we will do is set the current health to the health, so that whenever you set the health to 100, for example, current health also starts with that 100. Update methods, we don't need that one. We do want to add a new method. Let's make that a public void deal damage. This one will take damage, a specific integer, and then we're going to work with that to change our current health. So our current health, we want to set that one to the maximum of 0 and current health minus damage. Reason for that is I don't want to have negative health in this case. What I want is to simply stop at 0, so we are going to clamp the value essentially between 0 and the current damage that we might have incurred. If the current health is smaller than or equal to 0, and is exploding is false, or not is exploding. You could also write it like that. We are going to say is exploding is true, so that we don't reiterate over and over again in this method whenever we deal damage. We are going to create a new explosion game object, and that explosion game object is going to be a new instantiation of our explosion prefab that we want to link up. We are going to explode at the current position of our asteroids. And in terms of rotation, we are going to go with Euler rotation and just go with 0, 0, 0, because for the explosion, it doesn't really matter what the rotation looks like. So that we are going to do. Now you might be wondering, why did I create a variable for this explosion game object? Well, what I want to do is that game object, I am going to remove that one, or that explosion, I am going to remove that one from the scene after 1 second. And also the current game object, I want to remove that one from the scene after half a second, so that the asteroid disappears from screen after half a second, and that the explosion itself disappears from screen at after 1 second. Right. A couple more things to do. You can see that we haven't changed the health, but also that we haven't yet changed the explosion prefab there. So we will now have to link up the explosion to our asteroid prefab, or to our asteroid health controller. So you see the health is there. Current health, you could set it to 100, doesn't really matter. We are going to set the explosion, however. With explosions, big is always nicer. So I'm going to go with the big explosion. There it is, and assign that one as the explosion prefab that we have in there. Now, deal damage is done. Whenever we deal damage and the current health of the asteroid drops below 0, then we explode and we remove everything from the screen or from the game scene. But where is that deal damage method currently being called? I have no idea yet. Well, we want to deal that damage from the laser controller. The laser controller is going to trigger an enter into our asteroid. So it's going to fly into our asteroid. And whenever that happens, we are going to deal health. So what we are going to do is, again, go into our laser prefab, check that we actually added a collider there. So yes, that is good. This probably should also be a trigger. And then we are going to go in that laser controller to do something there. There's another Unity event function, and that is called onTriggerEnter. And when that method is called, or that event is fired, we can essentially check the current collision that is occurring. So what we are going to do is, first of all, check that we are not colliding our laser with the player. So we're going to compare the player tag, and if we are colliding with the player, then simply return, because we don't want to deal damage to the player. That player tag, by the way, is a tag that you will have to set inside Unity. I don't think we've done that yet. So let's go back into our full game scene, go to our ship prefab, and here in tag, you can set this one to player. You can also create your custom tags if you want, but in this case, we're going to tag the ship as player so that we know that when we're colliding with that player, we don't do anything and we don't deal damage. Then if the other .GameObjects .try get component, we are going to try and get the health controller component. If there is a health controller component, we are going to use that one as the health controller. There we go. Then we are going to call our health controller .deal damage. And let's say damage is going to be 25. So essentially every asteroid gets 4 shots, and then the asteroid should explode. If you would want, you could also create a field for the damage so that a laser can always have different types of damage, or depending on the velocity of the laser, you could do that, but I'll leave that up to you. That's gameplay, and that's however you want to structure things. I'm also going to destroy the current game object whenever we collide with the asteroid, because that means that the laser has arrived at its target, and we simply are going to remove the current laser from the screen in this case. Right, back into Unity. Let's jump into play mode, and let's see if we can shoot that laser. That's a long cooldown that I have there, so let's maybe also change that a little bit. In our game scene here, the cooldown that we had, let's go in, where is my script? Here it is. The cooldown is currently 1 second, which is a long time in between shots. So I'm going to change this one to 0.2, just because. And what I'm also going to do, by the way, is in the player controller, make sure that my current cannon is reset to 0, because I think I made a typo in there. All right, there we go. Let's try that one again. Go into play modes and shoot at our laser, and boom, it explodes. The graphics weren't great on my screen here, but that should be better whenever you have better graphics card in there. But our asteroid explodes. It is now removed from the scene as well, so it actually was destroyed, and I can navigate around. The ship flies around, and my my asteroid is gone. Now the problem is the asteroid is gone. There's no new asteroids coming in, so this is currently still a very, very boring game. The next thing we want to do, however, is dynamically start spawning asteroids on our game scene. So let's look at how we can do that. To spawn asteroids, we are going to create an empty game object on the scene, and that is going to be my spawner object. The reason I do this in a separate object is that I can easily find it in my current scene that I have and essentially find my spawner. Okay, this is a spawner, and then the spawner will have a script attached to it that does the asteroid spawning. So I mentioned script. Let's create a new script and call this one asteroid spawner. There we go. It's now added in our assets. We can go in there and we can start coding. I will again start with a couple of things that we will need as part of this thing. And that is setting up essentially the structure of this spawner. So we will need a serialized field to keep track of the prefab that is going to represent the asteroids. Again, I mentioned that we want to spawn asteroids, and this is going to be a link to the template object that we will use to be the asteroids. We also need a serialized field that is going to be a float in this case, and that's going to be my spawn interval, just to be able to control how often new asteroids are added to the scene. Let's also add a serialized field that is going to be a float, and that is going to be my maximum scale. And let's also add a minimum scale so that we can size the asteroids based on whenever, how they are created, and are they big, are they small, etc. Let's maybe also add some default values there. So for the maximum scale, let's do 10. For the minimum scale, let's do 5 and go with that. And we can change that later on in the scene because, again, these are serialized fields, and you can go into the inspector window to change those whenever you want. I also want to keep track of the current screen center. So vector3 screen center. Reason for that, again, is that I want to do calculations with that screen center on where do I spawn the asteroid on screen and so on. So let's do that. And I also want to keep track of a couple of floats, namely my minimum y, my maximum y, my minimum x, and my maximum x. Reason I'm keeping track of those is that in the start method, we are going to look up the screen center and then essentially say, look, I want to spawn asteroids between these coordinates, or at least outside of these coordinates that we have there. I'm going to capture the main camera. Doesn't really matter in the start method, but I mentioned that capturing game objects is kind of expensive in Unity. So in this case, I'm just going to cache the main camera into a variable so I can work with that one instead. My camera transform position is the next thing I want to keep track of. So for my main camera, I want to keep track of the coordinates of where it is so that I can use the camera again to calculate those coordinates where I want to stay out of. Then the screen center is going to be my main camera dot screen to world point, again converting the resolution of our screen to Unity's coordinate system. We'll take the screen dot width divided by 2. We'll take the screen dot height divided by 2, and then the z-axis can be 0 again. Right, so we now have the screen center, we have the boundaries of our camera. So the next thing we are going to do is set those minimum y, maximum y, minimum x, etc. Let's go with whatever Rider is suggesting here. I don't think that's going to be correct, but we can fix that later on. So for the minimum y, we want to convert a screen point to a world point, and that screen point is indeed going to be 0, 0, and then we are going to do the main camera transform position and take the z-axis of that one, because we want to have that as the minimum y. Again, because we changed the z-axis at the beginning of this tutorial, we want to keep track of that one in the game here. Maximum y is going to be the screen height, and again here we are also going to make use of that negative camera position z. For the minimum x coordinates, 0, 0 is good, but also here we are going to add that camera position again, and the maximum is also good, but also the z coordinate was off a little bit, so we're going to reuse that one. Okay, so perfect. Again, trying to find the boundaries of whatever we want to have on screen. Another thing our spawner is going to do is spawn asteroids, of course, and we are going to do that in a coroutine. Let's go with that. And we will have to implement that coroutine as well. So we start a coroutine, create a method called spawn asteroids, which is an IEnumerator, and this one can then start adding asteroids onto the screen. This is going to be a very simple method with a while true. And while true, what we are going to do is yield, essentially return something from this iterator. We are going to return a new, wait for seconds, and that is going to use our spawn interval. So we are going to wait for whatever we configured as a spawn interval, and only after that moment we are going to instantiate a random asteroid. Cool. There we go. Of course, one thing is still missing. That is our method that actually instantiates the asteroids that we have here. So let's create that one and see what we can do there. All right. There is some code that you could write to make sure that your asteroids do not spawn on top of each other and so on. There's a written version of this tutorial in the notes of this video. Go have a look at that one because we're doing a couple of things more there. Just for this video demo, what I'm going to do is simply use some randomizers to find a good position to spawn the asteroids that we have there. I'm going to keep track of the spawn X position. And I'm going to keep track of the spawn Y position. And this is where we will create our asteroid on screen. Our scale is going to make use of the Unity engine.random to get a value for what the scale of our asteroid is going to be. We are actually not going to use the value, we are going to use a range, sorry. We are going to use the range between minimum scale and maximum scale, so we don't have to think about that, and we'll get a scale for the asteroids that we are spawning. We're also going to create a do while. If you would do that check whether the asteroids are overlapping each other, doesn't matter in this case, so I'll just go with var random value equals unity engine.random.value. The random value is always going to be between 0 and 1. So what we are going to do is based on that random value, we are going to set the spawn coordinates of our code there. So if the random value is larger than 0.75f, so the top quarter of the random value range that we could get here, we are going to set the spawn x to be a range between minimum x minus maximum scale. Reason I do this maximum scale subtraction there is that if you have the screen boundaries, if you look, let's quickly go into Unity. If you have the screen boundaries here, whenever you spawn, I want to spawn outside of those boundaries, but not just here at this position. I want to also take into account what the scale of the asteroid could be, and maybe even spawn it here so that it doesn't just pop up on screen, so that we actually keep outside of the screen boundaries for a little bit longer to make it look more natural. We're also going to subtract the scale there because our scale might change, so let's do that. This is going to be using the minimum x minus minimum scale as the boundaries, and then also with the scale. Minimum y and maximum y, that's good. So this is the first case of where we could spawn asteroids. I'm going to copy this code and do the next thing for whenever our random value is larger than 0.5, because then we want to start spawning the asteroid in a different position of the screen. In this case, we want to use the maximum x plus the minimum scale plus the scale. And again, let's maybe demonstrate here. So in this case, we are going to spawn on the right-hand side of the screen. So we want to not spawn just outside of the boundary here, but we want to spawn here, somewhere farther away, so it just doesn't pop up on screen whenever you don't expect it. In terms of coordinates, let's remove this, and we are going to use our maximum x plus maximum scale plus the current scale. And then again, go with the y coordinate, which is going to be minus y and maximum y. Going to copy this one, and let's say larger than 0.25. We are going to flip the order. In this case, we are going to spawn on top and at the bottom. So our x is going to be between minimum x and maximum x all the time. And our y is going to be something different. In this case, not minimum x and all of that. It is going to be, let's quickly copy this one so I can reuse the logic and don't have to think about it too much. This is going to be minimum y. This is also going to be minimum y. Copy it once more, and that's essentially going to be every other case. This is going to be a copy of this one essentially, but then with the y coordinates so that we can spawn top and bottom. So this is going to be maximum y, and again, max y, and go with that. We have our coordinates ready now, so all we have to do now is spawn that asteroid object, so we can do that as well. For our asteroid object is going to be a new object that we instantiate. We are going to make use of the prefab that we assigned, namely the asteroid. The asteroid will be spawned at, let's quickly look at the code here. It will be spawned at a new vector tree, which is going to be our spawn position that we just calculated. So spawn x, spawn y, and then the z coordinate is going to be 0. We want to rotate it as well, but it doesn't really matter what the rotation is. So let's just go with 0, 0, 0. You could, of course, change that whenever you think that this might contribute to the game experience. Our asteroid objects, we're going to do a couple of things there because we want to make this game a little bit more interesting. The asteroids are not simply going to fly around on space. We always want the asteroids to look at and essentially move towards our player. So in this case, we are going to make use of this transform.lookAt method to look at the screen center. We could make this our player as well, like I just mentioned, but we could also look at the center. And then the last thing we want to do is our asteroid object. We want to transform it to be a local scale. That is going to be a new vector tree, and that is going to be our current scale, scale, so that we are resizing the asteroid that we have on screen. So that's pretty much it. I know it's a lot of logic, but it's essentially some coordinate juggling where we are looking at what's the center of the screen. And then based on the center of the screen and the random value, we are spawning just outside of the boundaries or outside of the bounds of the screen that we have here. Let's go back into Unity. Let's go to our spawner and then set our asteroid to something more interesting, namely our rock that we added. Spawn interval, let's go with 2 seconds just to make it fast. I'll maybe change the scale a little bit to be 2 and 1. Just so it's not massive and huge asteroids. And let's go into play mode and see how this works. There we are. We get new asteroids spawned. You can see it in the sample scene here. So they fly in. This is really cool. They all come to the center of the screen. Very, very nice. They are spawning. But the problem is that the moment our initial asteroid goes off screen, things are going to start and break down. Our asteroids, actually it should start and break down. Our asteroid has gone off screen, has been destroyed, and there's no more way to spawn new asteroids. So what we are going to do is remove our asteroids from the scene and also make it an asset. So what we'll do is drag it into the Project Explorer, create a variant of the prefab. So we essentially get an additive operation on top of whatever was in the asset that we downloaded first. Let's call this one Asteroids. And in our spawner, we can also remove the rock from the scene if you want. Our spawner is now going to not use the scene object, but it's going to make use of the asteroid prefab that we just created. All right, and this should be nice and should work and just spawn asteroids whenever we want to have it. All right, now the last thing I want to have is, and let's maybe check if it works, the game first. So we have asteroids coming in. We can fly around and we can shoot asteroids, and the asteroids do explode, and this time with a very nice explosion on screen as well. So this is really good. Asteroid exploding, and you see the shadows, you see the lighting. This is perfect. The only thing missing right now is a score. It would be really nice to keep track of the score whenever an asteroid explodes, that I increment the score so that I can move towards the highest score ever if I wanted to. So what we are going to do is on our asteroid spawner, we are going to add another component, and that is going to be a script. And in this case, we want to control the entire gameplay. So we are going to create a game controller. And that game controller is going to be a new script that essentially keeps track of the score value that we want to work with. So let's jump into Rider. And in here, start to add a couple of things. So first of all, I want to add a serialized field, which is going to be a GameObject, and that is going to be a score value object. The reason to have this serialized field is that I want to hook up some UI elements, and that UI element is going to be hooked up through this score value GameObject so that I can work with it later on. I'll also add a private integer, which is going to be the score, so that I can actually keep track of the score that is there. And then what I'll also do is create a new method, public void increment score. This could take a value with which to increment the score or whatever you want to do. What I'm going to do in this case is going to use the score and simply add 10 whenever the score is being incremented. And then what I'm going to do is on that score value GameObject, try and find the component that is a Text Mesh Pro text box, and we'll add that control in a little bit. And then for that control, we are going to set the text to the current score.toString so that we can keep track of the current score that is there. One more thing to do is in our health controller, we also want to increment the score whenever we actually deal damage to an asteroid. So when the asteroid is exploding, what we are going to do is in here, we're first of all going to check if the current game object that we're attached to in the health controller is not our player. If that's not the case, what we are going to do is find the game controller. And I should type this one correctly. So find the game controller tag, and that is essentially going to find our spawner game object that is in the code. Whenever I have that one, I'm going to get components. I'm going to get the actual game controller script from that one. And then on that game controller script, I will increment the current score. So whenever the asteroid explodes, this is going to find that game controller object and then make sure that the score is incremented. Quick thing to do in Unity, our spawner is simply untagged right now. And again, we are trying to find that spawner using that game controller tag. So what we want to do here is set this one to game controller tag so we can actually find it and do something with it. All right, the next thing we will need to do is add some UI. So what I'm going to do is add some text to the screen using Text Mesh Pro, and yes, import the fonts and everything that is there. And you will see that I now have a new canvas, and the canvas is always going to overlay the entire screen that we have, so the entire field of view. And we have our text that is sitting on there, and we could move that one around. And let's say we want to anchor it on the top left. And from the top left, we want to, let's put it somewhere in the corner and go with that. We can set the text to 0 to start with. And what we're going to do is on our spawner, now set that score value to the text that we just added. And that text component has an internal component that is the actual text. So this is the one that we're looking for and that we're also updating in our script that we just added. So with that, let's see if this works. We can press the play button. We can move our ship around, and let's wait for a couple of asteroids to come in and see if our score increases whenever we shoot at the asteroids. Let's do this. Yes, we now have a score of 10. Let's shoot some more. And there we go. The score keeps incrementing, and this is really nice. All right, with that, I hope I gave you a really good overview of how to get started with game development in Unity, how you could build an Asteroids game. In terms of gameplay, there's lots of things that we could still add here. For example, we could do a game over when too many asteroids hit the current player that we have. You can actually find, again, the written tutorial of this video in the description of the video. Have a look at it because there's a couple more things in there. The source repository is also linked, so if you want to go ahead and extend this game to your own liking, feel free to do so and give it a try. Till next time.